All right, this video is over graphing square root functions and cube root functions. So the square root parent function is f of x equals the square root of x. And if you type that in, you're going to have your graphing calculator open. So you may need to pull that up on your computer or on your phone, whatever you have it on. And so on your y equals, you're just going to type that in, the square root of x, and then go to your table and get your points. And it starts here at the origin. And then it has points at 1, 1, at 4, 2, and then it looks like 9, 3. Okay, so it's going to look something like this is what a square root function looks like. Okay, and our end point, that's just the starting point of where the graph is on here. And it's our end point on this one is going to be 0, 0. Our domain of this, talking about the x values, well, our x values start at 0 and then it hits all values that are greater than or equal to 0. So you say x is greater than or equal to 0. Our range is talking about the y values, and it starts here at 0 and it hits all of the y values that are greater than or equal to 0. Okay, so that's the square root parent function. The cube root parent function, so it's just the cube root of x. And same thing, you want to type that down under y equals and then go to your table to get your points. And your points are going to be 0, 0, 1, 1, about 8, 2, -1, -1, and -8, -2. And it's going to make this weird looking S, kind of like this. Okay, so on the last one, we had an end point, but this one we have a turning point, and that's going to be this center point right here. So where it turns from one direction to the other, and that turning point is going to be 0, 0. Our domain and range for these, because, well, for our domain, we have an arrow that goes to the right and an arrow that goes to the left. It's going to be all real numbers, and that should always be all real numbers. Our range, we have one that's going up and one that's going down. And so that is also all real numbers, and that should also always be all real numbers. Okay, so for the transformations part, it follows the same transformations that we've learned on other graphs. And the original transformations right here is a times the nth root, because n is either going to be talking about the square root or cube root, depends on which one we're using, and then x minus h plus k. The h represents the horizontal shift. If it's a positive, it shifts to the left. If it's a negative, it shifts to the right. The k represents a vertical shift. If it's positive, it goes up. If it's negative, it goes down. The end point or turning point is going to be your hk. If your a is negative, the function is reflected across the x-axis. So like on this cube root one, it would be this way. And then this square root one would make it go like this. If your a is greater than 1, it represents a vertical stretch. If your a is in between 0 and 1, it represents a vertical compression. Okay, so comparing to the parent function, it says describe the transformations of each function compared to the parent function. Okay, well, just looking at this, because this is a -7 right here, okay, that means it's going to shift right 7. And because this is a +2, that's the k, it's going to go up 2. So you say up 2. On this next one, we have a 4 in front. So our a is 4, which is greater than 1. So it's going to be a vertical stretch. So you say vertical stretch by 4. And then we have a -1, which is outside of the radical. So it's the k, so it's going to be down 1. This next one, we have a negative a right here, so it's going to reflect across the x-axis. And then we have a +3 under the radical, so that's your h, so it's going to go left 3. This one, we have an a of 1/2, so it's going to be a vertical compression by 1/2. And then we have a minus 2 underneath the radical, so that's your h, and so it's right 2. And then we have a minus 6 outside of the radical, so it's going to be down 6. Okay, all right, let's flip the paper over to the other side. Okay, so this top one, it says the square root parent function is reflected across the x-axis, then shifted 7 units left and 1 unit down. Write an equation that represents this function. Okay, so if the square root parent function is reflected across the x-axis, then that means that we know that it's going to be a negative at the front. And because it's square root, the index is 2. So we have f of x equals, we know it's a negative. Okay, and then it's square root, because it doesn't say anything about a vertical stretch or a vertical compression, so we know there's not going to be a number there. Okay, then it's shifted 7 units left. Well, left was a positive, so that's going to be x plus 7. And then 1 unit down was a negative, so then it's minus 1. Okay, and that's all you have to do. This next one, it says a cubed root function has a turning point located at -2, 3. Write an equation that could represent this function. Okay, so it's f of x equals, all they told us is that it has a turning point at -2, 3. And we know it's cubed root, so we don't know anything about the a, okay? But we know it's a cubed root. And our h is -2, okay? Well, our original transformation function says x minus h. So if you plug a -2 in that, then that turns a negative times a negative, makes it a positive. So that is x plus 2. And then we have plus 3 on the outside. Okay, so graphing radical functions. Graph each radical function, identify the key characteristics. Okay, so you can actually look at this and be able to graph part of it or be able to answer part of it just by looking at the equation. But if you want to get the exact points, or you should get the exact points to be able to graph it better, you can type this in on your y equals and then go to your table to get your table of points. Okay, this has a shift up of 5, and so we know it's going to start at 0, 5. 1, 2, 3, 4, 5. Okay, it also has a point at 1, 6. And then at, what is that, 1, 2, 3, 4, 7. And at 9, 8. Okay, so it's going to look like this. All right, so our domain starts here at 0 and it hits all values that are greater than 0. So you say x is greater than or equal to 0. Our range starts at 5 and hits all values greater than or equal to 5. So y is greater than or equal to 5. Our end point is this point right here, which is 0, 5. End behavior. So as x approaches positive infinity, okay, so we're talking about the right side of the graph. F of x approaches positive infinity because as x is going to the right, the y is going up, so it's positive. On the other side, it never goes past this point right here. So you say as x approaches 0, f of x approaches 5. Okay, so the other side of the graph is going to be your end point. The increasing intervals and decreasing intervals. Remember, these are only talking about the x values. Okay, on this particular one, it is only increasing, so there's not going to be any decreasing intervals. So it starts increasing, the x values increase from 0 to positive infinity. And you put a bracket there because it is a point that starts at 0. Okay, all right, so the next one, so type that in on your y equals, and let's go to your table. And you have a point at 1, -4. 2, -3, 5, -2, and 10, -1. Okay, so our domain starts at 1 and hits all x values that are greater than or equal to 1. Our range starts at -4 right here and hits all values that are greater than or equal to -4. Our endpoint is 1, -4. Our end behavior, as x approaches positive infinity, so this right side over here, f of x is going up, so it's positive infinity. The other side of the graph, it's the end point. So as x approaches 1, f of x approaches -4. It is only increasing because it's only going up right here, so there's no decreasing intervals. So it increases from 1 to positive infinity. So 1 to positive infinity. Okay? All right, number 9. So type that in on your y equals, and then go to your table. We start here at -1, 0. We have a point at 0, 3. We have a point at 3, 6. And a point at 8, 9. That's what it looks like. Somewhere over here. Okay, so it's going to look like this. All right, so our domain, it starts here at -1 and hits all values that are greater than or equal to -1. Our range starts at 0 and hits all values that are greater than or equal to 0. Our endpoint is -1, 0. In behavior, as x approaches positive infinity, f of x approaches positive infinity. The other side of the graph, it's the endpoint, so -1, 0. It is still only increasing, it's going up here. Remember, this is decreasing, this is increasing. Okay, so our increasing intervals start from -1 to infinity. All right, let's look at the next one, the next sheet. Okay, all right, so number 10. So you want to type that in on your y equals and then go to your table. Okay, this, because it has a negative up here at the front, it's going to flip the graph down. Okay, so we have a point at 2, 3. We have a point at 3, 2. At 1, 2, 3, 4, 5, 6, 0. And looks like that's about it. Something kind of like that. Okay. All right, so our domain, so it starts here at 2 and hits all values that are greater than 2. So x is greater than or equal to 2. Our range starts at 3, but then it's going down. So it hits all values that are less than or equal to 3. Our endpoint is 2, 3. Our end behavior, as x approaches positive infinity, f of x approaches, well, it's going down this time, so it's going to approach negative infinity. Okay, the other side is going to be our endpoint, as x approaches 2, f of x approaches 3. This time our graph is going in this direction, so it's decreasing, so there's no increasing intervals, and it's decreasing from 2 to positive infinity. So 2 to positive infinity. Okay, all right, these next ones are going to be cubed root functions. Okay, so make sure that you pay attention to whether or not it's square root or cubed root. These are cubed roots, so it's a different graph. Okay, type that in on your y equals. Remember, you can get the cubed root function by going to math, and then I believe it's number 3 or 4 that you hit to be able to insert that in onto your y equals. Okay, these points we have, let's see, -3, 2. We have -2, 3. -4, 1. 1, 2, 3, 4, 5, 4. It's really all about the I see on this particular graph. I'm not actually typing it in. I'm just looking at the graph that they have drawn on the note sheet. I don't have a calculator on hand right now to be able to graph this. But it should look something like this. Pretty close to that. Okay, all right, so the domain for this, well, we have arrows going opposite directions, so it's gonna be all real numbers. The range, same thing, all real numbers. Our turning point is gonna be this point right here, which is -3, 2. Our end behavior, as x approaches positive infinity, f of x is going up, so it's positive infinity. The other side, as x approaches negative infinity, it's going down, so f of x approaches negative infinity, okay? Since it is in this direction, it's going to be increasing. The whole thing is increasing. So you mark out the decreasing, and for increasing, it is increasing from negative infinity to positive infinity. Okay, on the next one, so type that in on your y equals. We have our point at 0, 0. We have a point at -1, 2. We have a point at -8, 4. Point at 1, -2. And a point at 8, -4. Okay, so our domain is going to be all real numbers because it's opposite directions. Our range is all real numbers because it's opposite directions. Our turning point is going to be right here, which is 0, 0. Our end behavior, as x approaches positive infinity, f of x approaches negative infinity because it's going down. On the other end, as x approaches negative infinity, f of x approaches positive infinity because it's going up. Okay, this time we have a decreasing intervals. So mark out increasing, and then on decreasing, you would say negative infinity to positive infinity because it hits all of the values that it's decreasing the whole time. Okay, all right, and then this last one here, so type that in, and we have points at -1, 1, 2, 3, -5. And then we have points at -2, -5.5, and at 0, -4.5, at 7, -4, and at -9, -6. So it's gonna look something kind of like this. Okay, all right, our domain is all real numbers, opposite directions. Range, all real numbers, opposite directions. Our turning point is this point right here, which is at -1, -5. Our end behavior, as x approaches positive infinity, it's going up, so f of x approaches positive infinity. The other end, as x approaches negative infinity, it's going down, so f of x approaches negative infinity. This time it's all increasing, so mark out the decreasing. It is increasing from negative infinity to positive infinity. Okay, all right, to sum up all of this, let's look at our graphic organizer here. Okay, I've already filled in some of it. So the square root function, the parent function is f of x equals the square root of x. The domain is x is greater than or equal to 0. Our range is y is greater than or equal to 0. Our endpoint is 0, 0. This is what our graph looks like. Okay, so some examples of this. On this example right here, okay, so type that in and well, our endpoint here is going to be -1, -3. Okay, so we know it's going to start right here, and then you can type that in on your y equals to get the rest of your points. And it looks like we're going to have a point at 0, -2, at 3, -1, and at 8, 0. So it'll look like that. So our domain starts here at -1 and hits all values greater than that. So x is greater than or equal to -1. Our range starts at -3 and hits all values greater. So y is greater than or equal to -3. Our endpoint is -1, -3. Notice how these numbers are always the same right there. Okay, example 2. Our endpoint, there's no h here, so it's going to be 0, 6. Okay, this time it's a negative, so it's going to end up flipping the graph down. Okay, we have a point at 1, 5. We have a point at 4, 4. And a point at 9, 3. So it'll end up looking like this. Okay, our domain, it starts here at 0 and hits all values greater than that. Our range, it starts here at 6 and hits all values less than because it's going down. So y is less than or equal to 6. That's the only time that you're going to end up using a less than or equal to when you're talking about square root functions like that. So if this is a negative that flips downward, it's going to be less than or equal to. Okay, and our endpoint is 0, 6. All right, so then cube root functions. So the parent function is f of x equals the cube root of x. Looks like this. Our domain is all real numbers because it's in opposite directions. Our range is all real numbers, so it's down and up. Turning point is 0, 0. It's always that middle point. Okay, so our transformations here, so an example, our turning point is going to be 2, 0. Right here. Okay, then you can type that in on your y equals to get the rest of it. The domain and range on these are always going to be all real numbers. Okay, they're always going to be in opposite directions. Okay, so our points on this, we're going to have a point at 1, -1, a point at 3, 1, and then it looks like a point at 1, 2, 3, 4, 5, 6 at -6, -2, and at 10, +2. So it's going to be something like this. Okay, for the other one, okay, we know this is all real numbers, and our turning point is going to be -5, 4. Okay, to get the rest of it, it is going to be a little bit different than that because we have a shift right here. We have a vertical stretch of 2. So we have points at 1, 2, 3, 4, 5, 6 at -6, 2. And at -4, 6. And at 3, 8. And it looks like that's about it on there. On the whole numbers, at least. So it's going to look something like that. Okay. All right. So that is square root functions and cube root functions.